Hello, ladies and gentlemen, and welcome back to another Fallacy Friday. I want to apologize in advance here for this homeless look. I do, in fact, have a home, and I'm working on this, but sorry. Last week we talked about appeals to the law, and this week we'll be talking about the Gamblers Fallacy, which is also called the Monte Carlo Fallacy. Without further ado, let's get started. The Gambler's Fallacy is the belief that infrequent events will become more frequent, and frequent events will become less frequent. Now, I don't want to scare anyone off, but I will be using some math to demonstrate the fallacy. We'll start with an example of a coin toss. I'm assuming that this is a fair coin and that each toss is independent. What this means is that the probability of getting heads or tails is 50% or 1/2. Let us start off by saying that I flip the coin 5 times and I get heads, 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 and heads. What will I flip the next time? If you answer tails, then you are committing the gambler's fallacy. How dare you! If you answer heads, then you are committing the hot hand fallacy. How dare you! We'll cover that fallacy later. Finally, if you didn't answer, you either realized that there was an equal chance of heads or tails, or you just weren't paying attention, in which case, wake up, because we're going to learn today! The probability of flipping 6 heads in a row is the same as flipping 5 heads in a row and then a tails. Each have a probability of 1.6%. Every flip has the same probability as long as you make the same number of flips. Every possible combination will always have the same probability. Getting 1 heads or tails will always be 50%. Getting any combination of 2 flips will be 25%. Getting any combination of 3 flips will be 12.5%. Because the coin flips are independent and fair, getting heads frequently won't necessarily lead to getting tails more frequently. We can also show why the gambler's fallacy is wrong with a die. Let us assume that we're using a 6-sided die that is fair, and to win, you must roll a 6. We're given 6 rolls to roll a 6. Under the gambler's fallacy, one would assume that the more you fail to roll a 6, the less likely your failures would become. Turns out the opposite is true. For every time you fail to roll a 6, your chance of rolling a 6 actually decreases. The probability of rolling at least 1 6 in 6 attempts is 1 minus the chances of not rolling a 6, which is 5/6, since there are 5 possible rolls other than a 6, to the 6th power, since we have 6 separate rolls. This probability would equal 66.5%. Now let's assume that we failed to roll a 6 on the first try. Now we only have 5 attempts to roll a 6, giving us a probability of rolling at least 1 6 of 1 minus the chances of not rolling a 6, which is again 5/6, to the 5th power, since now there are only 5 attempts. This gives us odds of 59.8%. So the more often we fail, the less likely we are to succeed given a set number of attempts. Alright, I will lay off the math for now and tell you why it is also called the Monte Carlo Fallacy. It is called such because back in 1913, when my parents were born, a roulette ball fell in black 26 times in a row at the Monte Carlo casino. There was only a 1 in 67,108,863 chance that that would occur. However, like we discussed earlier, every spin of the wheel had an equal chance of falling on red or black if we ignore green. Gamblers lost millions as they incorrectly assumed that red would have to be the next one since black had been so frequent. In conclusion, just because something happens frequently doesn't necessarily mean it will happen less frequently in the future, and vice versa. I'll see you guys next week. And always remember that math is fun.